In this short mini-course, we're going to take a look at astrobiology, the search for life beyond our own Earth. We have 5 sections: an introduction, a look at life, a look at how life got started on this planet, possible locations for life elsewhere in our own solar system and beyond, and how we might go about detecting this extraterrestrial life. Life as we know it only occurs on Earth, but Earth is just one planet among many in our solar system, among many solar systems in our galaxy, and our galaxy is one of hundreds of billions in the universe. So, statistically speaking, is it even likely or possible that we here on Earth are the only living beings in the universe? Astrobiology is searching for the answer to that question. How did life originate on our planet, and did it actually originate here? For how long has there been life on Earth? Where did it come from, and what other types of places besides Earth might be capable of supporting life? How has life changed over time on this planet, and would it be the same in other places? Is there life on other worlds in other places in our universe? And if so, how similar is it to life here? If it's not similar to life here, why or why not? Would we even be able to communicate with them if we found them? We are searching for these answers. If there is not life anywhere else, why not? What makes Earth so special? What does that tell us about our place and our importance in the universe if there is no life anywhere else? Historically, this is not a new topic. People have considered the possibilities of alien life for centuries. Metrodorus, Giordano Bruno, Huygens, Lowell, Sagan, dozens and dozens of people, historical figures throughout time, have considered this. Do other stars have planets? Do these planets have living things? Does this exist in our solar system, or perhaps in other solar systems surrounding other suns? Huygens believed that Jovians, living things from Jupiter, and Venusians, living things from Venus, loved music. Percival Lowell believed that Martians were building canals to route water from polar ice caps to drier areas of the planet. Herschel thought that Lunarians from the moon had circuses. But even much more recently, some of the footage that we're getting from our robot spacecraft and rovers find formations that could be caused by biological processes. This picture of Martian cauliflower, or these microfossils that appear to perhaps be from bacterial origin coming from Mars. Could there be or have been things living there? Here you see an image of famous astronomer Carl Sagan pictured with a model of Viking 1 that traveled to Mars back in the 70s. Here we actually had some experiments that were looking for life on Mars. Now, even though the experiments were inconclusive, meaning it did not prove the existence nor the absence of life on Mars, we've been looking for quite some time. More recently, in 2012, the Curiosity rover found some of these rounded pebbles. And if you compare the Mars side of the photo to the Earth side of the photo, the pictures look very similar. And anytime on Earth we find these rounded pebbles, that's occurring because of an erosive process involving liquid water. And on Earth, whenever we find liquid water, we find living organisms. So we're considering the fact that conditions on Mars may have been such in the past that even though liquid water is not existing on the surface of Mars today, that perhaps it was in the past. The Cassini spacecraft that has been in orbit around Saturn for quite some time discovered on one of the moons of Saturn, Enceladus, cryovolcanism. What you see in this image is water from the subsurface being shot out of what amounts to being frozen volcanoes, spewing this water as ice crystals into space. If there is an ocean below the surface of this moon, is it possible that there could be life below the surface? Now, it may not be Enceladin fish, but it could certainly be bacterial in nature. The easiest way, perhaps, to find these other living things would be in considering how life developed on Earth, what kind of things living things on Earth required, and then trying to find those same things, those same conditions elsewhere in our universe. Perhaps life had developed in those places as well. However, keep in mind, though, that if we do find life, it doesn't mean that it's intelligent life or that we would even be able to communicate with it. Bacterial life anywhere else in our solar system or in the universe would still be very, very significant if it especially represents a separate genesis of life than what took place here on Earth. So taking a look at our solar system, from the Sun, Mercury, Venus, Earth, and Mars, we have the terrestrial planets closest in toward the Sun, separated by the asteroid belt from the gas giants, Jupiter, Saturn, Uranus, Neptune, and the host of moons that surrounds all of those planets. Beyond that, we have the Kuiper belt and the Oort cloud. Our solar system is incredibly complex. One of the things that we want to look at is how our solar system came to be, and how might that be similar or different from all other solar systems in the universe. We're starting, remember, with a nebula, a star-forming region, a cloud of gas and dust in space. In this image, you see a picture of the Orion Nebula. It's about 20 light years from us, and what you see in those individual stars in the center are very, very young stars that are just developing from this condensing cloud of gas and dust. As the gravitational attraction is pulling all of this material together, what we see are young baby stars forming. This set of 4 stars here is called the trapezium. This is a small asterism in this nebula. And these stars, rather than being several billion years old like our sun, may only be thousands or maybe only a few million years old. As this area of gas begins to be drawn in by gravity and collapsing, we start to have a protostar forming in the middle of this protoplanetary disk. So the star starts to condense in the center as other materials start to group together in the disk, forming early planets. A star is considered to be born when nuclear fusion begins. Hydrogen, the simplest element on the periodic table, has only a mass of 1. Helium, the next heavier element, has a mass of 4. So it takes fusion of 4 hydrogens together to make a helium. As the gas and the dust in the nebula continues to condense into the sun and other individual planets, these planets will interact with each other gravitationally, sometimes even kicking other planets out of the solar system or having smaller planets combining into bigger planets. We're looking for something that stabilizes in the habitable, or what's sometimes called the Goldilocks zone, having just the right conditions so that they're not too hot that water boils away, but not too cold that all the water freezes. We want it to be just right. Now, in the case of our early Earth and our solar system, we formed about 4.6 billion years ago. Now, that being said, the oldest rocks that we have on Earth do not date that far back. But consider why you think this is in looking at this image. Keeping in mind that the rock cycle is constantly changing one form of rock to another, and as the material remelts into magma, we actually lose most of these oldest rocks in remelting events as all of these small planetesimals are merging together to form our Earth. Also remember when we were talking about the moon, we mentioned that our Earth was actually impacted by something probably about Mars-sized that actually ended up creating our moon. This happened during a period called the Late Heavy Bombardment, and this would have actually pretty much liquefied our entire planet Earth, erasing any rock record that we had prior to that point. The oldest rocks that we have found on Earth are found in Greenland, in what's called the Isua region. We also see very, very old rocks in some areas of Western Australia and other lava-type rocks that have been metamorphosed over time. Early Earth, though, would have been very, very hostile to living things. Volcanoes erupting constantly, comets and other asteroids bombarding Earth would have made it a very unpleasant place. Oxygen would have been very, very low in the atmosphere. No ozone layer would have led to extremely high levels of ultraviolet radiation. Carbon dioxide would have been very high, not only being released from volcanoes, but not being recycled in any kind of photosynthetic processes yet. Would have been much colder because the sun was still in its very early stages, not nearly as bright, not nearly as hot as it is today. But there would have been liquid water still depositing these sediments over time. So even though conditions on early Earth were not such that life would have been possible early on, we are making progress in that direction. These early rocks do not contain any type of fossil evidence that we have found so far, but Earth is making progress. Volcanoes continue to change the composition of the atmosphere. Comets continue to bring water and other volatile materials to Earth's surface, and as Earth changes over time, it will soon become habitable to these early organisms. In your first mini project, you're going to select an astrobiologist, a science, a writer, a philosopher from this list. Each person is going to have a separate individual so that there are no duplications. What you'll create is a document, a poster, an informational way to convey all of the information that's important about your particular historical figure, including at least one quote related to astrobiology. Take a look at the list. When you've finished with this section, let me know who you're interested in, and I'll let you know whether they've been selected or not, and continue to the final slide to see an example of what you're going to produce. This is an English writer and physician, Sir Richard Blackmore. You'll see that he lived back in the late early 1700s. He wrote about many medical topics, including the bubonic plague, smallpox, tuberculosis. He also wrote a lot about religion and creation. One of his quotes in one of his books says, "We may pronounce each orb sustains a race of living things adapted to the place. Our world's sun becomes a star elsewhere." To me, I think this is important in terms of astrobiology because these quotes show that Blackmore believed that our sun was just one of many, many stars. That when we look out into the sky at stars, someone else may be looking back at us, at our sun, as just one of many stars. And that each one of these stars could have planets with things adapted to life in that environment living on them. I used an app called PicCollage to create this. You can do something in Microsoft Word, you can use PicCollage or a variety of other apps to create your informational poster about your important historical figure.